Every journey into the universe begins here, on Earth, with the light that reaches our world after traveling for millions of years. Long before telescopes, our only tool was a human eye, gazing into a much darker sky than most of us ever see today. But now our instruments push our vision farther than ever before. So how far can we see? From Earth, we see the moon in stunning detail, but only one side of it. The moon keeps its far side permanently hidden. In 2007, Japan's Kaguya spacecraft gave us the moon as we had never seen it before. High-definition footage and the first truly cinematic views of Earth rising above the lunar horizon. In 2019, China achieved something no one had ever done, a soft landing on the far side of the moon. Because the far side never faces Earth, the mission used a relay satellite parked at gravitational sweet spot, a Lagrange point, allowing signals to bounce around the moon and back home. Through this link, humanity saw the hidden moon from the surface for the first time. Today, NASA's Lunar Reconnaissance Orbiter maps the moon with unprecedented precision. It can see tracks left by Apollo astronauts, measure crater shapes, and create a complete 3D map, including the far side. From simple eyes on Earth to spacecraft orbiting and landing on the unseen side, every generation extends how far and how clearly we can see. Venus is the brightest object in our night sky after the moon. A brilliant planet we see clearly with the naked eye. But its thick clouds hide the entire surface. To reveal it, NASA sent the Magellan orbiter using radar to map the planet through the haze. Mercury is the hardest planet to see from Earth, visible only for moments at dawn or dusk. Our first real encounter came in the 1970s, when Mariner 10 became the first spacecraft ever to use a gravity assist, slingshotting past Venus to reach Mercury. Decades later, NASA's Messenger orbited the planet and mapped its entire surface, revealing a shrinking geologically active world with ice hidden in permanent shadows. And now, ESA and JAXA's Bepi Colombo is making its long journey toward Mercury. Only the second spacecraft ever to orbit the planet, and by far the most complex. So close to the Sun, Mercury is harder to reach than Saturn, and remains the least explored world of the inner solar system. The Sun dominates our sky, but it's far too bright and too dangerous to look at directly. Even a telescope or binoculars can cause instant permanent blindness. To study the Sun safely, we send a spacecraft built to face its heat for us. NASA's Parker Solar Probe dives closer to the Sun than any spacecraft in history. It used a series of 7 gravity assists around Venus to spiral inward, eventually flying through the Sun's million-degree corona. There, it measures the solar wind and magnetic fields that drive space weather across the solar system. Farther out, ESA and NASA's Solar Orbiter carries the most advanced solar telescopes ever flown. It captures the closest image of the Sun's surface, maps its magnetic activity, and will reveal the mysterious polar regions, key to understanding the Sun's 11-year cycle. Alpha Centauri is our nearest stellar neighbor, a triple star system just over 4 light years away. Its 2 main stars, Alpha Centauri A and B, shine brightly enough to be seen with the naked eye from the southern hemisphere. With powerful tools like the Hubble Space Telescope, we can resolve the pair in detail and study the properties far beyond what our eyes can detect. The third star, Proxima Centauri, is a faint red dwarf, far too dim to see without a telescope. We cannot image its planets directly, but astronomers detect them through indirect methods. Tiny wobbles in a star's motion and subtle changes in its light. Using these techniques, they discovered Proxima Centauri b, an Earth-sized world in the habitable zone, orbiting every 11 days. Once, the Milky Way was a familiar sight in the night sky. Today, light pollution hides it from most of us. And even in perfect darkness, we can never see the whole galaxy from the outside. We live inside its rotating disk. But with powerful observatories, we can trace its structure from within. Infrared telescopes like Spitzer, WISE, and VISTA can look straight through the dust that blocks visible light, revealing hidden stars and star-forming regions. Radio observatories such as ALMA and other large dishes can detect the faint signals from hydrogen gas spread throughout the galaxy, allowing astronomers to map our spiral arms. And Gaia measures the positions and motions of over 1 billion stars, giving us the most detailed map of the Milky Way ever created. At the heart of the Milky Way, stars orbit around an invisible mass of 4 million times the Sun, clear evidence of a supermassive black hole. The Event Horizon Telescope, which is not a single instrument, but a global network of observatories linked together, has now imaged black holes directly. 2017, we get our first image of a black hole in galaxy M87, and later confirming the shadow of our own Sagittarius A star in the center of the Milky Way. Andromeda is the most distant object visible to the naked eye, a faint blur of ancient light 2.5 million years old. With binoculars, its shape appears, and a small telescope reveals its bright core and dust lanes. Large observatories on Earth resolve individual stars, but space telescopes take us further. Hubble shows Andromeda in sharp visible detail, while the James Webb Space Telescope, working in infrared, looks through the dust and uncovers hidden structures where new stars are born. Beyond Andromeda, the universe opens into structures far larger than any single galaxy. The Milky Way is part of the local group, nested within vast superclusters like Laniakea. Across hundreds of millions of light years, galaxies trace enormous filaments separated by cosmic voids. Hubble and Webb reveal these structures in light and infrared, while radio telescopes like ALMA follow the gas between them. And in the largest clusters, gravity itself bends light, letting us glimpse galaxies far beyond our reach. At the very edge of what we can detect lies the cosmic microwave background, the oldest light in the universe, released just 380,000 years after the Big Bang. It is a faint afterglow filling all of space, mapped by satellites like COBE, WMAP, and Planck. And it marks the limit of how far light has traveled to reach us. Beyond this horizon, we cannot see, not because there is nothing there, but because the universe once was opaque. And as we look outward, we discover something even more surprising. The universe is expanding faster and faster, driven by a force we do not yet understand. A reminder that even at the edge of sight, the cosmos still holds mysteries far beyond our reach.